Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem. Just attempt to solve it, talk through my thought process, and hopefully it's useful to someone watching this. So the problem that we're going to be attempting to solve today is from LeetCode's 150, and it's longest consecutive sequence. So I'm just going to read through the spec here. Given an unsorted array of integers nums, return the length of the longest consecutive elements sequence. You must write an algorithm that runs in O of n time. So, you've got 100, 4, 200, 1, 3, 2, then the output's going to be 4. Otherwise, it's going to, it's going to be 1, 2, 3, 4 because if it's 100 or 200, yeah, these are not connected in any way, but these are right next to each other. So, I guess what we kind of have to do is I'm just gonna take this into notes. Let's go into notes and write down some ideas. So let's take this as an example, right? Input is nums. So I guess the naive approach in this example would be to sort nums. Then iterate through until. Oh no, it wouldn't even be to sort nums. It would be. Yeah, I don't even know what the. We need to. Do we need to sort them? Right, we don't technically have to sort these. We just have to find how many of them are connected. So can we have some sort of upper and lower bound? So let's say this is just off like would this work? So we go to nums and find or iterate through nums, and we can only do one iteration. We only can go O of n. So worst case is O of n. Iterate through nums. Okay. If nums is not in, say scene, right? We're going to call this scene for now. Now, if we have to see if a number exists in an array, that's an O of n operation. So what we're going to have to do is create a dictionary. Yeah, we're going to have to create a dictionary. Create a dictionary. We could even call this like groups. Create a dictionary called groups. Iterate through nums. If num is not seen in groups, add it to Can we do that? Add it to groups. Add it to groups. Can we add it to groups? So a groups is just going to be like the groups of numbers we have. But it's going to be like, let's say for instance, groups is going to be a dictionary, right? So groups is going to be equal to a dictionary, right? But we need to have some way to store. So let's say we go to 100, right? We want to find 100 in the dictionary, and if we don't find it, we're going to add it. But I don't know how we're going to add it. We're going to, I think the number that goes into groups, the key is going to be the number that we're looking for. So let's say we put in 100, right? The numbers that we're then going to be looking for are the consecutive numbers. So we're going to be looking for either 101. So let's say go to 100. 100 is not in groups. Add it to groups. And so we're going to have groups, and it's going to be have 10, and it's going to have 101, and it's going to have 99. Yeah, it's going to have 101. It's going to have 99. Yeah, it's going to have 100. Is that right? Is that right? 100, 1, and 99. So you want to then... Because this is the only way you're going to have an O of one if you put it in a dictionary. Accessing keys or accessing like items in a dictionary is an O of one operation. Um, Create dictionary called groups. Yep. Add groups. But there could be the case that you start with like 1 and 2, and then you create a group, and then you have 4 and 5, you create another group, but then 3 comes along, and it turns out that you've duplicate keys, which can't happen because there's 2 groups that are both looking for the same next consecutive element. So don't know how we're going to do this. No, I'm a bit stuck here. Go to 100. 100 is not in groups, add it to groups. I think what I'm actually going to end up doing is watching through some of the LeetCode, or not LeetCode, the NeetCode, like, I don't know what you would call it, like almost like his walkthrough for this, because I found that with there was another problem, and it was array of product of array except self. That is a problem that I spent, I think it was probably like a good half hour on, and I just could not solve it. I watched one of these NeetCode videos for 3 minutes. He didn't even write any code, and after the first couple of minutes I was like, I know exactly how to solve this. Went back, tried to solve it, and it was really not, I wouldn't say easy, but like I understood the theory behind it, and I was able to implement it. So I think when I initially started this, I said I'm not going to look at any videos, I'm not going to look at any solutions, but I think that as long as you're not memorizing the solution, as long as you're if you're trying to gain like problem solving skill, not even problem solving skills, if you're trying to understand the kind of techniques behind some of the popular kind of techniques behind LeetCode problems, and the sort of structures, the same sort of structure that a lot of LeetCode problems follow, you can. I don't know what I'm getting at here, but I think it would be best to kind of watch this and see if I can understand the theory behind this question to begin with. So we're gonna go type this into Google, open it in a new tab. Oh, that's not what I meant to do. I meant to Google this. And here we go.
Step into Wix Studio, where creative freedom meets absolute efficiency.
Let's solve LeetCode 128 longest consecutive sequence. This is a pretty interesting problem, and it's actually been asked by a lot of companies, including Google, for coding interviews. So
okay, so I mean, if it's good enough to be asked at Google, then
I think it's a good problem to understand. So we're given an input array of
oh, that's interesting. This used to be classed as a hard problem, but it got downgraded to a medium. That's funny.
Numbers, right? In this case, we have 6 numbers, and we want to find the longest consecutive sequence. In this case, the longest consecutive sequence is 1, 2, 3, 4, right? It doesn't matter what order the numbers appear in the input array. We just want to know the longest consecutive sequence that we can make from the input array. Now, the most obvious way to solve this problem is just by sorting, right? So if you look at the sorted array over here, we have obviously one consecutive sequence of length 4, right? 1, 2, 3, 4. They're all consecutive numbers. We also have another one that's length 1, just 100. And we have the last one that's also length 1, just 200, right? Now this is...
So that would be... It would be an O of log n times n solution. So it's just like a O of n times log n solution, I think. Is it would be O log n to sort the input array, and then it would be O of n to actually find the longest sorted subsequence.
This is definitely a valid solution. We can definitely code this up, but the time complexity is going to be O n log n.
Yep.
So the question is, can we do better? So this is a LeetCode hard. Obviously, the solution wouldn't be this simple, so we can do better. But how do we get there? Now, the first thing to do is try to visualize the problem in a way that it makes the problem really easy to understand. So I visualize the problem by drawing out an imaginary number line, right? So we can kind of see what the sequences actually look like. This makes it a lot easier to recognize the patterns. So we know we have one sequence that starts at 1, 2, 3, and 4. We have another sequence that comes after it with just one number, 100. We have the last sequence with also only one number, 200. So just by looking at it, we can tell we have 3 distinct sequences, right? That's something to recognize. Now, by visualizing it, we can kind of try to approach how would a human solve it? Well, the easiest way is just look at each of the sequences, right, and count how long they are. So let's look at the first sequence, right? We have 1, 2, 3, and 4. So this sequence has 4 numbers in it. We have the second sequence, just 100, so it only has 1 number in it. So it's a sequence of length 1. The last one is also a sequence of length 1. Now this is so easy to solve when you visualize it and try to approach it how a human would, but can we actually convert this into code somehow?
So this number line is kind of what I was trying to achieve with the groups dictionary data structure, but it's just the way that the implementation I think is quite difficult.
The answer is yes. So the most important thing to notice is that we have 3 sequences, but how can we identify what makes a sequence? How can we actually start at the beginning of a sequence? the thing to notice, and this is really easy when you actually look at the picture, that each sequence has a start value. The start value, in this case, the start value for the first range, or the first sequence, has no left neighbor. The first value 1 has no left neighbor, right? That's really obvious. Look at the second range, 100. It doesn't have a left neighbor. The third range, 200, doesn't have a left neighbor. So we can get the start of each sequence by just looking at our entire array of numbers, right? And figuring out which numbers don't have a left neighbor. So meaning if we wanted to check if 1 had a left neighbor, we would check, does our array contain the number 0? If we wanted to know if 100 had a left neighbor, we'd check, does the array contain 99? The easiest way to do this and the most efficient way to do it is by taking our initial array and converting it into a set. So now to find the start.
Okay, turn it into a set, so that would be an O of n operation, I think.
Start ranges, let's start iterating through our array. So we get to the
that's O of n. I'm not sure.
First element, 100. Does it have a left neighbor? Well, we can check our set. It doesn't have 99 in it, so this is the first, so this is the start of a sequence. So let's get the length of the sequence. We start at 100. Now to get the length of this sequence, we want to count how many consecutive numbers come after 100. So we want to know, does 101 exist in our sequence? Looking at the number line, obviously it doesn't, but how can we check this efficiently with code? Well, we already have a set that takes up this entire array, so let's just use our set to check if 101 exists. Since it doesn't, we can no longer continue this sequence. So now we get to the next number, 4. Is 4 the start of a sequence? Let's look at our picture we drew. 4 is not the start of a sequence, and we can check this using our set. We would check that it does have a left neighbor, right? 3. So it's not the start of a sequence. We're not going to make a range from it. We get to the next number, 200. Is this the start of a sequence? Looking at our picture, yes it is, and we know that 199 does not exist in our set. So let's make this sequence.
Now, are all of these operations are of O of n, right? O of n. Because you're doing 4, or so let's just say 100, you're looking for 101. You have to loop through the entire array to find that item. Or 4, if you want to find the next item, again, you have to loop through the entire array. Is there anything down here that's saying? Looping over the set is faster than looping over the array. Looping over the set is faster than looping over the array if there are duplicate values. Since this video came out, I think they've added new test cases with lots of duplicate values. No, it should be. That's O of n squared then, right? If you were looping over it, each if you're looping over it for every number that it's going to be O of n squared, because you're doing an O of n operation for each number, so it's O of n squared. Is that right? I'll keep watching.
Let's try to make it as long as we can. We check, does 201 exist? No, it doesn't. We can tell that from our picture, and we would use the set to determine that. So now this is as long as we can make this set, so let's get to the next number, 1. Is 1 the start of a sequence? At our picture, we can tell 1 does not have a left neighbor, so it is the start of a sequence. Now let's check if 2 exists in our set. It does, so we can make this sequence a little bit longer. Now let's check if the next number, 3, exists in our set. Yes, it does, so let's make it even longer. Now does 4 exist in our set? Yes, it does.
So
now let's check if
again,
5
looking over this is
exists in our set. It doesn't, right? There is no 5, so we can't make this sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor 2. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure. Since we only had to iterate through the entire array and we had to expand each range, we know we had to iterate through the entire array and we had to expand each range. We know that we're only going to visit each number at most twice, so our solution is very efficient. And we did.
I don't understand that. I would have thought this is O of n squared. Because you go through your array, right? You go 100, check is 100 in the set. Then let's say 100 was down here, you'd go 1, 2, 3, 4, 5, 6. That's O of n, O of n operation. I'm gonna look down here, see if anyone's pointed this out. I think it's me that's misunderstanding this. Yeah, this solution gives a TLE now. I believe it's still not an O of n solution, since there is a loop inside of a loop, and give a long sorted input. Duplicate first and non-left accessing nature won't this loop run wild. Yeah, if this was O of n, every sorting algorithm for space is not important, would use this behind the scenes. Yeah. So, it looks like this solution. Oh, very nice explanation, thank you. I think this would be useful to have this note. In Python, set is implemented as a hash table. So you can expect to look up, insert, or delete an O of 1. I did not know that. So, set in Python. Okay. I'm just gonna say set in Python. Time complexity. That's interesting. In that case, yes, it would be an O of n operation. Or an O of n algorithm. So let's go back to our notes and kind of work off of that. So we can keep this for now, but what we're going to do is create a set called set underscore nums. So we've got a set. Then what we're going to do is loop over the initial kind of, or loop over nums. Check if num is in set underscore nums. And then I'm just going to say this is O of n. So, oh no, not O of n, sorry, O of 1. Checking if it's in, checking if it's in the set. No, it's not even checking if it is in the set. It's going to be in the set, but checking if num plus 1 is in set underscore nums. If it is, set its left neighbor. Don't know how we're going to do that. Set its left neighbor to how are we going to do that? Set its left neighbor to, how are we going to do this? Let's switch back to the video here.
Three sequences, but how can we identify what makes a sequence? How can we actually start at the beginning of a sequence? The thing to notice, and this is really easy when you actually look at the picture, that each sequence has a start value. Doesn't have time into iterating first. So this is the start of a sequence. So let's get the length of the sequence. So we want to find now the start of a sequence. No sequence. At our picture, we can tell one does not have a left neighbor, so it is the start of a sequence.
Okay, so we could probably have like a dictionary called, like, we could keep this group's dictionary somewhere.
Now let's check if 2 exists
slightly
in our set. It does, so we can make this sequence a little bit longer. Now let's check if the next number 3 exists in our set. Yes, it does. So let's make it even longer. Now does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make this sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor too. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So is length 1. So this is the length. Created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure. Since we only had to iterate through the entire array and we had to expand each range, we know that we're only going to visit each number.
Okay. I think one thing I was actually going to suggest is, can we loop over set? Can we loop over the set? I think we can. Loop over set. If num plus 1 is in set underscore nums. Okay, so if it is, set its left neighbor to nums, to num. We could also keep like a max value. This is just some idea. So set max to, or set current underscore current, or just we're going to call it combo to 0. Max underscore combo is going to be equal to 0. So we're going to set the combo equal to 0 over for every single iteration. Check if num plus 1 is in the set. If it is, set its left neighbor to num. So, in fact, we don't even need to Do we need to do that? How? I'm just gonna switch back to this video again.
Since it start of a sequence, now let's check if 2 exists in our make it in our sequence. No, it's not. It has a left neighbor 2. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we want. The third 1. Does 2? Now does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make this sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor 2. Now let's try.
What I was going to suggest is we can maybe remove the items as we're going along. So iterating while removing. Oh wait, you can't. Can you remove items from a set? Remove item from set Python. Okay. So we want to remove the item from the set, but can we do that while iterating? Delete item from set while iterating over it. Okay. Let's go back to notes. We even need to set a left neighbor. I don't think we need to do that. So check if it is in there. Check if the num+1 is in set underscore. Oh no, I can't actually do that. Yeah, it could be the case that you're looking at a number and you start looking at 1, right? Or you start looking at 2. That's the first item in your set. So you look for 3, 4, 5, 6. And so you've got 2, 3, 4, 5, 6. You've got 5 items. And you remove them as you're going along. But then your next item is 1. So you then say, okay, starting from 1, the max consecutive, the longest common subsequence is just 1, which is wrong. It should be, what, 6? So that's not right. So we can't remove them. I've got that part wrong. So the left neighbor thing would work. So we'll have to use another dictionary for that. So we need to create a dictionary call it left neighbor. Okay. So we're gonna check if num+1 is in set nums. If it is, add it to the left neighbor. That's not useful neighbor. Is it? Yeah, that's useful. Neighbor, I think. I don't know. Add it to the left neighbor dictionary with set it to the left dictionary neighbor with num as its value. Increment combo by 1. Repeat this part until you can't find num plus 1. Okay. So you have like let's try this. So we can, yeah. So let's just try doing a dry run of this. So we go to 100 and check. We'll go to 100. Yeah, we go to 100. We then check if 100 plus 1, 101, is in the set. That isn't, so we go to oh, we should also say if it is what can we say? Check if num plus 1 is in set underscore nums. If it is, just try to think about this. So if we start with, if we find a number and it's not in the left dictionary, left neighbor dictionary, we shouldn't add it. If it is, and it is not in the left underscore neighbor dictionary, if it's not, if it is, and if it is in set underscore nums, and it is not in left dictionary, if it's not in left neighbor dictionary, add it to left neighbor dictionary with num as its value, and continue to the next number in the set. Cool. So we go to 100, we check if 100 plus 1, 101 is in the set. It isn't, so we go to 4. 4, we're just going to say 5. 5 isn't in the set. We go to 200. So 1 isn't in the set. We go to 1. 1 plus 1, 2 is in the set. So we add it to so we add it to set combo equal to 1 to start off with, right? So 1 plus 1, 2 is in the set, so we add it to left underscore neighbor. Like so. So it's going to be something like 2 colon 1. Okay. We increment combo. It is now 2. Yep. In fact, is that right? Let's just go with it for now. The increment combo is now 2. We increment combo, it is now 2. Okay, let's just keep going through it. We look for 2 plus 1, 3, it is in the set. So we add it. Set to the dictionary. So we're going to be looking at something like this, and then we increment combo. It is now 3. We increment combo is now 3. Okay, I don't think we need this combo variable. I think it's kind of useless. We look for we now look for what? We'll now look for 3 plus 1, 4. And it's in the set, so we now add it to the dictionary. So left neighbor is going to be looking at going to be looking like 4, 3, and then, well, what am I saying now? We increment combo, is this what I'm saying? We increment combo. It's now 4. Okay. Then what I'm saying is we we look for we increment combo in the 4. We look for 4 plus 1, 5. It is not in the set, so we continue to the next number in the set, which is 100, or no, 200. No, we've done 1, so we look for 3. Okay. So we can now say we're looking for 3. We look we go to 3. We look for 3 plus 1, 4. In the set, it is in the set yeah, it is in the set, and it is also in left underscore neighbor, as you can see here. It is also in left underscore neighbor. So we it's also in left underscore neighbor, so we continue to next number. I'm actually going to do something different. I'm going to put 5 at the end here and see how this goes. Oh no, actually I can see here we look for 5 here. That doesn't make sense. I'm going to remove this. What I'm also going to put down here is set if combo is greater than max underscore combo, then max underscore combo is equal to combo. Okay, it's also in left neighbor, so we go on to the next number. Okay, next thing we do is we go to, so we've done 3, we go to 2. We look for 2 plus 1, 3 in the set. It is in the set. It's also in left underscore neighbor, so we continue to the next number. Cool. We are at the end. Return max underscore combo. I don't think this is going to work, but let's try it anyway. It's a lot of pseudocode. So let's start off. Max underscore combo. It's going to be set to 0. We're going to have a set called set underscore nums. That can be created at a later point. In fact, no, we can just say set underscore nums is going to be able to set nums. Yep. Okay. We're going to loop over this set. So for num in set underscore nums. What we're going to do is combo is going to be equal to 1. If num plus 1 is in, or we don't have to say is, if num plus 1 in set underscore nums, then if it isn't set underscore nums, then we're going to check if num plus 1 in left underscore neighbor. How do you spell neighbor? O-U-R. If num plus 1 in left underscore neighbor, or if it is not in, then we're going to do left underscore neighbor at index num plus 1 is going to be equal to, or at key num plus 1 is going to be equal to num. Cool. Then we're going to do combo is equal to, or is plus equal 1. Combo is going to be incremented by 1. Yeah. That's right. Right? I'm going to do something cursed and make this a while true loop. It's just going to keep on looping. So, increment combo by 1. So if it's in the set, so what we're going to do is, oh no, can you just say while num plus 1 is in set underscore nums. If it is while num plus 1 in set underscore nums, we're going to check this. Else break. Cool. And then what we're going to do, repeat this until you can't find num plus 1. And then we're also going to say here we're going to say max underscore combo is equal to combo, but we need a little conditional before here. We need to say if combo is greater than max underscore combo, then this. What else do we need? We need a left neighbor dictionary. And over a fat, this is gonna throw some sort of error. This is not gonna work. Return max underscore combo. I will be very, very surprised if this passes first try. Okay, let's print nums, or print num. How many times does it actually enter this loop? Okay, it actually loops through everything. Can we print num, but can we also print left underscore neighbor? Okay, this is pretty much exactly what I had written down. If I scroll down here, I had 2, 1, 3, 2, 4, 3. That's exactly what I'm looking for here. So there's something wrong with this like combo code. Maybe I need to put this. Let's put this here. We don't. We can do the conditional there. It's not gonna be that expensive. Oh no, that's totally wrong. Right. Let's see what combo we get to. So it should be a combo of 4. We'll say combo, and then we'll also say... Oh, we always say num plus 1. Can we say... Can we say num plus combo? Oh. And then here we can say num plus combo minus 1. That's a very roundabout way of doing things, but that passes. This actually passes. Will this actually work? Will this spaghetti code actually pass this? I'm really hoping it does. Come on. Come on. Oh, come on. So close. 50 out of 75 test cases passed. Okay, let's just start saying if length of nums is equal to 1, then return 1, right? Use this test case and run. This is a little edge case. Right, okay. Submit. It's gonna run. What? Oh, set underscore nums. Use this test case. Okay, these test cases now pass. Submit. Come on. Why doesn't this work? So combo is equal to 1. Okay. If num, which is going to be 1, if 1 plus 1 is in this, well, okay, it's not, it's going to go into the next number. If 0 plus what? Can we print the... what you call it? We'll just print the dictionary every time. Hit run. So let's run this. Oh, sorry, I didn't say that there. Okay, so we have 0, 0. So let's actually just print set underscore nums here. Okay. So while so we're gonna say if minus 1 plus 1. Oh, that's not even right. It shouldn't be 0 here. It should be minus 1 here. So while num plus combo is in set underscore nums. So while so we're going to say that's going to be equal to 0 plus 1, right? So we're going to say while num plus combo is in set underscore nums. So we're going to say if 0 plus 1, which is 1, is in the set, which it is, we're going to see if it's in left underscore neighbor, which it's not. We're going to set left neighbor to num, which at this point is 0, plus combo, which is 1, so 0 plus 1, or, yeah, 0 plus 1, which is 1. Okay, wait, so this one's going to be discounted, so we go into the 0, 0, 0 qualifies for this, so it goes into here. 0 is not in left neighbor, so left neighbor at index num, which is 0, plus combo, which is 1, so 0 plus 1, which is 1, minus 1, at index 0, it's going to be equal to 0. The index is going to be looking for 0 plus 1 minus 1. So num plus combo is 1. Num plus combo is 1. 0 plus 1 is 1. Minus 1 is 0. Why have you got the minus 1 in there? That's what I'm confused about. Because down here we want to set, so we look for 2, right? So in here, why I can't remember why we've got this minus 1 in here. Okay. it should be equal to num plus combo, right? No, num plus combo minus 1. Okay, that's looking better, but our combo's still not correct. So we then go to minus 1. Minus 1 plus 1 is in set underscore numbers, because it's 0, right? It is in there. I'm going to print num here as well. So 0 is in there. We should see here, or minus, yeah, minus 1. Yeah. That's weird. So as minus 1, it enters the loop twice. So can we go down here? Oh, we check if it's in the left neighbor. So if we check if num plus combo is not in left neighbor, what if we take this out? Just comment this out and indent, comment this out and unindent this. If we run this, are we gonna, can I get a bunch of, oh no, this could work, this could work, this is gonna work, please tell me this works. I probably shouldn't have uncommented that, but let's just hope and dream. Let's hope and dream this submits. So close, yeah, so far. So in this case, the max combo is 1. I think if we change this up here to 1, and we hit run, that will probably fix that. It's just another weird edge case. Okay, let's hit submit and hope. Let's see if it's empty, it's going to be equal to 0. We shouldn't need that weird edge case thing anymore. Okay, accepted. So if we take this out now, please tell me this runs. Right, take out all the print statements. Add this test case. Hit run. Is it actually running? It's just because there's so many numbers? Oh, come on. That's annoying. That's really annoying. What if I move this check here out here? Will that work? Nope. I think I'm going to leave it at that because I've spent over an hour on this, and I'm going to come back to it another day. Thank you for watching me struggle with this for over an hour. Hope this was useful to you in some way, or if you have some other suggestion to help me here, it would be great. It would be greatly appreciated. So, yeah, please leave a comment to help me out here, and yeah, hope you enjoyed watching me suffer here. But yeah, thank you once again for watching the video, and I hope you have a great day. Bye.